So the angle of incidence is 30. Now, when we trace the original part, this must be it. Okay. If we extend this line, this is the angle of refraction. This is the angle of deviation. This is the lateral displacement D. The lateral displacement is always perpendicular to this, so we can extrapolate it from this point to this point, and it will be the same as this. Meaning, if you have an object here, 2 pins placed here, which we often use in rectangular glass prism experiment. When an observer looks at it down here, the observer sees the image of these 2 pins, P1 and P2, over here. It means that the image, okay, it seems to be shifted by this distance. So that's why we call this as lateral shift, D. Now, the question demands that we calculate for D. Let me go back to the question. So, when the light illustrated in figure P35, which is this, passes through the glass block, it is shifted laterally by the displacement at the distance D. If the refractive index, absolute refractive index of the glass block is 1.5, so N we are given is 1.5. The refractive index of the material is 1.5. Let me check, okay. Okay, so I'll increase the font size, okay. So the refractive index we are told is 1.5. What is the value of D? Then 17, we find the time required for the light to pass through the block, the glass block. So our first requirement is to find the value of D, the lateral shift. But you see, from what we were doing last time, if this point is labeled A, this is B, this is C, this is D, this side is perpendicular to this, and this side is also perpendicular. It means that when we consider triangle ABC, okay, now we know that the angle of deviation sigma would be equal to the angle of incidence minus the angle of refraction. So we will need this angle, which is the deviation. Okay, so let's first and I've been sent information. So this is from Marvelous, are you there?
Yes, please.
So I won't buy your reason. Meaning the angle of deviation can be determined when you subtract R from I. I we know is 30, but we don't know R to find the deviation. Is that okay? So let's first find the value of R. When we use absolute refractive index is equal to sine of I over sine of R. So that when we make sine R the subject, we have sine I on the refractive index. We have I. I is 30, so sine 30 degrees over the refractive index, which is 1.5. Sine 30 is 0.5, so 0.5 divided by 1.5. Please calculate it for me. 5 on 10 times 10 on 15. Okay, so we have 1 on 3. Okay, 1 on 3. So sine R is equal to 0.33333 recurring. Therefore, R will be equal to the sine inverse of 0.33333. And marvelous, what is the sine inverse of 0.333? Help me determine R. R will be equal to, anybody, if you are ready, please call it out for me.
Mr. Dua, please, 19.47.
So 19.47. Thank you, Deborah. We've rounded it. So this is the angle of refraction. Okay. Now, if the angle of refraction is this, then it means the angle of deviation would be equal to 30 minus 19.47, which would have to give us, yes, 10 points what? 10 point.
10.53.
So 10.53 degrees. So we have R, we have sigma. We can go ahead to find whatever we are looking for. So when we consider triangle ABC, okay, if we take the cos of R, cos of this angle R, this is equal to the adjacent AB. Of course, we know AB. That's the width of the prism over the hypotenuse AC. Okay, AB is 2 centimeters. So let's put that there, 2 centimeters. R we know. So cos of R, which is 19.47, is equal to 2 over AC. Of course, once we have all this, we can find AC. But let's hold on. If we take the sine of sigma, this is equal to opposite, and that is D over the hypotenuse. They all share a common hypotenuse, AC. Okay. Sigma we know. So sine of 10.53 is equal to D over AC. All right. Now, let's make AC the subject in this equation and in this equation and equate them. Okay, if we make AC the subject in equation 1, we have AC is equal to 2 on cos of 19.47. If we make AC the subject in equation 2, we have AC is equal to D over sine of 10.53. Once we've made AC the subject, let's equate. It means that we can equate this to this. That 2 over cos of 19.47 is equal to D over sine of 10.53.
It
Hello?
sounds like a boy.
Pardon? So from this relation, we can now find D. Make D the subject, and D would have to be equal to 2 times sine 10.53 over cos of 19.47. So the rest has to do with calculator. What is sine 10.53? Give me the value in 3dp. When you finish, multiply that by 2. Sine 10.53. This times 2. This is equal to 0.3655. Okay, divided by cos of 19.47. Cos 19.47. And this is equal to 0.9428. So when you divide the numerator by the denominator, 0.3655 divided by that, D is equal to 0.388 centimeter. So that's the value of the lateral displacement D. Please, are we okay? Are we fine? Nana Jemfua and the rest of you who had a challenge, are you okay?
Please, can you go back again?
Yes, please.
Okay, so all that we are doing here is consider this triangle. Don't forget, I gave you a formula. I gave you a formula. So consider this triangle. Use refractive index formula, sine I over sine R, to find R. Because you have N, you have I, you can easily calculate for the angle of refraction using refractive index. Okay, and that gave us 19.47. But you know that angle of incidence for refraction, angle of incidence is equal to angle of refraction plus angle of deviation. So once you have R and you have I, Irene, can't you determine sigma, the deviation?
Yes, please.
Good. So 30 minus the value of R would give you sigma. Once you have R and D, this is a right angle triangle. This is also a right angle triangle. When you consider triangle ABC, okay, considering triangle ABC, cos of R will be equal to the adjacent over the hypotenuse. Here, all that we are doing is that we don't know hypotenuse. If we get this, if we find the hypotenuse, you can easily find D. So, in fact, I was just playing around to create a relation. But in actual fact, once we have cos 19.47 and we have 2, you can easily find AC using equation 2. When you get AC, then AC, this triangle and this triangle share a common hypotenuse. So once you have this angle, you can easily use the other triangle to find D. But I was just trying to play around it. That's how come I equated them. But in actual fact, you use this to find AC. When you have AC, you can easily substitute it into the other triangle to find D. Please, are we fine? Are we okay? All right. So
Yes.
Irene, just make time to look at it again, and that's it. With the solution, you can easily follow. The second question. Find the time required for the light to pass through the glass block. Find the time required. So we are looking for the time required for the light to pass through the glass block. Okay. Now here, we are looking for the time required for the light to pass through the glass block. But what is the path of the light? When the light is passing through the glass block, this is the path. AC would be its path, because ideally this is where it has to go. But because of different densities, it has been shifted. So this is the path, okay, or the distance traveled. If this is the distance traveled, if I manage to get the velocity of light in the medium, I can easily find the time. Okay, because its distance or its path is AC. We have AC. We have AC. AC, we got AC is equal to 2 over cos of 19.47. So we can easily calculate for AC. Okay, but because speed or velocity, because velocity is equal to distance over time, T would be equal to the distance over V. The distance we can easily determine from AC, but we don't know the speed of light in the medium glass block. Don't forget, it is moving from air to glass. So the speed will be the speed of light or the velocity of light in the medium. Please, are we okay? Are we fine? All right,
Yes,
so I
please.
want to, let me clear this part. Just this part to make way for the calculation. So we also understand that refractive index can be expressed in terms of speed of light. Once the light is from air to glass, speed of light in air over speed of light in a medium. Speed of light in air is constant. So when we make V the subject, we have C over N. So we have 3 times 10 to the power 8 divided by the refractive index, which is 1.50. So simply, the speed of light in the medium is equal to 2 times 10 to the power 8 meter per second. And this is the speed of light in the glass block. Okay. So let's calculate for the time taken. T is equal to distance over velocity. The distance is AC. Now, what did we get for AC? Please calculate for the hypotenuse for me, since that's the path. Calculate for AC. We have AC is equal to 2 over cos 19.47. So give me the value of AC in 3 decimal place. 2 divided by cos 19.47.
Mr. Dia, please, 84.104.
84.
0.104.
I want to confirm. So that if it's not correct, I can beat you. It's not 84. It's 2.121. 2 divided by cos 19.47, Deborah. It's 2.12 centimeter. Please, let's have a seconder. I shouldn't be the only one calculating, or Deborah. Please, did you get that? Priscilla, are you answering or talking? Now, you see?
This is
2.12. 121.
yeah.
Since the speed of light in a prism is 2 times 10 to the power 8 meter per second, we can have this distance AC in centimeter to work with. When we do that, it is wrong. So we have to convert this to SI unit. So 2.12 centi is 10 to the power negative 2. So having done that, then the distance is divided by the time. V is what we calculated here, 2 times 10 to the power 8. So divide 2.12 by 2. This divided by 2, we have 1.06 times 10 to the power negative 10 seconds. That's the time. So this is the answer for the time taken for the glass, the light to pass through the glass prism. So beautiful. Okay. So let me check attendance. Edubia, Akofala. Okay, Adelaide. Okay. Anita. Right.
Mr. D.
You are all welcome.
Mr.
Do
D.
you have, hello?
Please, my line was breaking, so what does the AC stand for?
The AC is the distance traveled by the light through the glass prism. This distance.
Okay. Okay. So
Please,
is it 2.12?
Yeah, the distance, when we calculated, we got 2.12 approximately.
Okay. Thank you.
Welcome. Please, any more questions? All right. I'm giving you work, which you do later. Do I clean the board? Hello, do I clean the board?
Yes, please.
Okay. I'm giving you assignments. Please, those of you who are fond of not presenting or submitting your assignment, I don't want to mention names, but you know yourselves. Please, try as much as possible to present something, okay? It may not be the best, but giving the attempt and then contacting me for your challenges is rather positive than just keeping it without attending to it. There are a lot of you who would send it. I have to sometimes even call them to explain their mistakes or challenges to them. So let's all embrace it and then work on it. I'm begging you. Okay, so the assignment is this. A ray of light falls on a glass plate. A ray of light falls on a glass plate of refractive index 1.5. So the refractive index of the glass plate is 1.50. 1.50, which is the same as 1.5. A ray of light falls on a glass plate of refractive index 1.5. What is the angle of incidence of the ray? What is the angle of incidence of the ray if the angle between the reflected ray and the refracted ray, if the angle between the reflected ray and the refracted ray is 90 degrees? If the angle between the reflected and the refracted ray is 90 degrees, this is the diagram. The boundary between the two. So this is a normal end. Light is incidented from less dense rare medium into a denser medium. Okay, so obviously light, the path will be deviated towards the normal. But whenever light incident at a boundary, part of it will be reflected and part of it will be refracted. Okay, so this is the refracted ray. And we have the reflected ray. The reflected ray as this. We are told that the angle between this, the angle between the refracted and then the reflected ray is 90. Okay. This is the angle of incidence. This is the angle of refraction. Don't forget, angle of incidence is equal to angle of refraction. So the question demands that what is the angle of incidence of the ray if the angle between the reflected and the refracted ray is 90? So we are actually looking for I under this condition. When the refractive index of the glass denser medium is 1.5. In fact, whoever gets this correct owes me or would owe me tasty chef after reopening. Akwavala, what's the problem?
Mr. Dia, please, could you briefly go over the question again?
Hey, Akwavala. I've closed
The
the
line
question.
was breaking.
Please, I want one of you to read it out for us. I just closed the page. Nana Jemfua, read it for us, okay?
His a ray of light falls on a glass plate of refractive index 1.50. What is the angle of incidence if the angle between the reflected and refracted ray is 90 degrees?
Please, can you?
Hey, Nana Jemfua, what a speed. Okay, Nana Jemfua, I'm here. A ray of light falls on a glass plate, a glass plate of refractive index 1.50. Okay, what is the angle of incidence of the ray if the angle between the reflected and the refracted rays is 90 degrees? What is the angle of incidence of the ray if the angle between the reflected and then the refracted ray is 90 degrees? Okay, so that's it. In fact, whoever gets it correct, I owe you.
Thank
I owe you, tasty chef. Okay. If you are more than 20 something people, if everybody gets it correct, in fact, I'll still owe you, tasty chef. Okay. So let's move on to another part. We've done refraction of the deviation of light in rectangular prism. There is another observation. You see, when you put a stick in water, in a cup of water, the part of the stick or the pencil between the air and water boundary always appear as if the pencil or the pen is bent. And I'm sure you have all made this observation before. Correct?
Yes, please.
The pencil always, or if it's a pen placed in a cup of water, it always appears bent within the air and water interface. 2, when you put a coin, okay, on a table and you place glass block on a coin and you look at it aerially or from above, it always appears as if the coin is closer to you than the real situation. Have you also made that observation before? Or when you visit the swimming pool in a hot afternoon, and then you stand at the edge of the pool and you look beneath it, it always appears the bottom of the pool has been raised up.
Yes,
it appears shallow than the real situation. When you fill a bucket with water and look at the bottom of the bucket, it always appears as if the bottom is closer than it is. These are all optical illusion that occurs as a result of refraction of light. I remember when we were kids and we were fond of visiting the